Tesla is currently developing a product that will change the world. An electric car for the mass market, the first electric car that will be truly affordable, accessible, and practical for consumers all over the world. This next-generation platform will put Teslas on the road in countries where they have never been seen before and into the hands of people who would have previously said that electric cars are just too expensive. This is a tall order because Tesla isn't interested in making a flimsy, low-quality bargain bin vehicle just for the sake of getting it at a lower price. They want to make a proper Tesla that wouldn't seem out of place next to a Model 3 or Y, just a little bit smaller and a lot more economical. Tesla has been dropping hints for years now on how they are going to accomplish this. So, while the vehicle itself might remain a well-kept secret, we already know a lot of the design and engineering elements that are going to lie at the heart of this new vehicle platform. So, here's what to expect from Tesla's next generation of electric car. The base platform for the next generation Tesla was actually revealed way back at the end of 2020 at Tesla's Battery Day. Elon announced that the company was developing a new car with a target retail price of $25,000 US. Now, obviously the value of a dollar has changed over the past few years, but so has the cost of an electric vehicle. The market overall is becoming more affordable, so even with inflation and other stuff, the price target is still within reason. At the time, Elon identified two primary factors that would allow Tesla to bring down the cost of manufacturing. One was a change in battery cell chemistry. He projected that in the future, Tesla would transition away from using a nickel/cobalt battery cathode broadly across their entire lineup. Instead, a new high-nickel, low-cobalt cell would be reserved for long-range and high-performance applications only, while standard-range vehicles would transition to a low-energy density, iron-based LFP battery cell. The change in chemistry, when combined with an increase in manufacturing efficiency and a decrease in raw materials cost, was projected to bring down the overall cost of a Tesla battery pack by 56% per kilowatt-hour of energy. Thing number two was a major change to the design of the skateboard platform. Instead of a traditional stamped frame consisting of hundreds of small parts fastened together by welds, bolts, and adhesives, Tesla reimagined their platform in three key segments, with a structural battery pack at the heart that serves dual purpose as a container for the cells and an ultra-rigid center frame, and flanked on both sides by die-casted frame segments for the front and rear quarters. This is a system that Tesla was able to fully realize with the Model Y produced at Giga, Texas in 2022, but that vehicle and the manufacturing process behind it were not designed from the ground up to take full advantage of the structural battery pack and Giga castings. They improved upon what was already there, but there was still a lot of efficiency being lost on the production floor. The next generation platform fixes this. Tesla designers and engineers introduced something they call the Unboxed Process at Investor Day in 2023. The old way of doing things with electric cars was to build the skateboard platform and the vehicle body separately, then bring the two main assemblies together, integrate them, and then install the interior and the finishing touches. With Unboxed, they break the vehicle up into smaller sub-assemblies, basically front, back, middle, sides, and outer shell. So what they can do is build out the entire front section of the vehicle as one sub-assembly. Starting with the single Giga casting, they add the drive unit, steering, suspension, brakes, heat pump, battery electronics, headlights, frunk, dashboard, computer, touchscreen, and steering wheel all together. At the same time, they can build the entire rear section in the same way. They even go ahead and install the rear seats. At the same time, they paint and finish the side rails so that they can be used to join the front and rear assemblies. At the same time, they bring in the structural battery pack with the full carpet, center console, and front seats pre-installed that simply comes up from the bottom. Then the glass is installed, the pre-finished doors, hood, and trunk are bolted on, the wheels are attached, and you have a complete vehicle ready to go. The theory here is that you can only work on a particular assembly from four sides at once, and there is only a certain number of people or machines that you can fit into a given space. So by breaking the vehicle up into chunks, you are increasing the surface area of the work by allowing all sections to be tackled from 4 sides at once, and thereby increasing the total density of workers or machines across the entire vehicle. Plus, you're giving them easier access to their work by keeping the sub-assemblies unboxed right up until the final assembly process. So, the overall impact is a 44% increase in operator density and a 30% improvement in space-time efficiency, and that translates in the end product to as much as a 50% reduction in manufacturing cost on a production floor that is up to 40% smaller. So that's the core philosophy behind how Tesla will make their next generation vehicle more affordable. It's not so much about cutting costs as it is about drastically increasing efficiency. Cost cutting will get you a cheaper car, but also an inferior quality of product, while increasing efficiency also brings down the price, but without having to sacrifice the standard of quality. There's even more to the equation of building a truly affordable electric car than just mastering the battery pack and the manufacturing. You need a holistic approach to every major component of the vehicle. That's why Tesla has designed an all-electric motor for their next-generation vehicle. The goal here is lower cost and higher efficiency. No surprise there. And the designers are achieving much of that cost reduction by eliminating rare earth metals from the motor composition. Beginning with the Model 3, Tesla started to introduce a permanent magnet DC motor into their vehicle lineup. This was a change from the original AC induction motor used in the first Model S and Model X platform. Permanent magnet motors have an inherently higher efficiency than alternating current electromagnet-driven motors, and that allows for the combination of both long range and high power that Tesla became so well known for. The downside to a permanent magnet motor is that they are typically based on the element neodymium, which is found way down at the bottom of the periodic table in the rare earth category. It's not that neodymium is particularly scarce in the overall composition of the Earth, but it is difficult to locate near the surface, and you typically won't find large concentrations all in one place. So, therefore, the cost is relatively high and the supply is relatively low. But engineers like neodymium for electric motors because it has a strong magnetic field that won't degrade over long periods of use, so it does justify the cost. Now Tesla is saying that they can get by without the need for any rare earth elements in their new magnet. So what will they use instead? A widely popular material for making magnets is called ferrite. This is a ceramic material of mostly iron oxide, also known as rust, combined with additional metals like manganese, nickel, and zinc. But it doesn't particularly matter which one. You'd find ceramic ferrite magnets in everything from speakers to electric guitars and cordless drills. They also help keep your refrigerator door closed, so a very common and very affordable material. The downside of ferrite compared to neodymium is magnetic strength. You would need a much larger quantity of ferrite to match the strength of a neodymium magnet, and there's not much extra space to go around inside of an electric motor. We know that Tesla can make some of this back by increasing efficiency. They've done that in the past. Just in the time between the Model 3 and Model Y, the engineers were able to reduce the amount of rare earth material required for the electric motor without sacrificing any power. But inevitably, by switching over to a ferrite magnet, Tesla will lose some performance in their next generation vehicle. So now, instead of going 0 to 60 in 6 seconds, it might take 8 or 9 seconds. Is that the end of the world? Absolutely not. This is a vehicle for the mass market. The average Joe is going to assign a much higher priority to cost than they ever would to performance. And Tesla can still make an upgrade option to dual-motor all-wheel drive for anyone who really wants an extra boost. The final piece of the puzzle here is Tesla's redesign of the vehicle's low-voltage electronics. So by that we mean anything that's not tied into the main battery pack. That one only powers the drive unit. All of the cabin electronics, lights, heating, and cooling is all powered by a secondary battery. Traditionally, that power would come from a 12-volt lead-acid battery, typically just referred to as a car battery. But no more. Tesla has upgraded their secondary battery to lithium-ion chemistry across their vehicle range, and that gives them the ability to now push the voltage up as high as they want. Beginning with the Cybertruck this year, Tesla will be going to 48-volt power. So why did they do that? The full answer is complicated, and we're not going to go there today, but in simple terms, if the load is kept constant, the load here being the vehicle electronics, then a higher supply of voltage allows for a lower current of electricity. High currents require large conductors, so by going to a lower current, you can actually reduce the physical size of your wires, fuses, switches, and other electrical components. Reducing the current also reduces heat loss in the system. Doubling the current will increase heat losses by a factor of 4. So by the same metric, having the current cuts heat losses down to 1/4. So higher voltage results in higher efficiency, lower cost, and lower weight. If you've been following along for a while, these ideas should all sound somewhat familiar. The next generation vehicle is just a manifestation of the core philosophies that Tesla has been built on. The constant search for greater efficiency, first principles thinking, the machine that builds the machine, the best part is no part, designed for manufacturing, it's all coming together in one single platform. That's what's going to make this vehicle so impressive, not just in its affordability, but also in the massive scale of production that Tesla will achieve. This new car, whatever they're going to call it, will change the game forever. Don't forget to give this video a thumbs up today if you liked it. That is so important for getting our content out to more people. If you enjoy the content, then you'd probably also enjoy our weekly newsletter. So sign up with the link down below at theteslaspace.com. A huge thank you to all of our Patreon supporters who are listed on the screen now. You help us make the best content we can, and we really appreciate it. Thanks for watching, and we'll see you in the next one.